Hi, we will start chapter 7 from these lectures, and this involves study of flow through pipes. Okay, so before we come to this exact topic, you can say that based on geometrical configuration, based on the geometrical configuration, fluid flow can be divided into two types. Okay, one is external flow and another is internal flow. Okay, so external flows, by external flow we mean flow over solid objects. Okay, so you keep a solid object in the flow. Okay, this is the solid and the fluid flows over this solid. Okay, this can be the streamlines. Okay, so flow over solid objects comes under the category of external flows. So example in this category can be flow over automobiles, okay, or aircrafts or tall buildings come in the category of external flows. Okay, so in general there are no outer boundaries to obstruct the flow. Okay, the domain is infinite. Right, and the external flows are the subject of next chapter. Okay, in the next chapter we are going to talk about external flows, where we develop the idea of what do we call as boundary layer. Okay, this is what we are going to do in the next chapter. Okay, the second classification or internal flows. Okay, this is actually flows, I would say, within the area formed by solid boundaries. Okay, so example, the main example is flows through pipes. Okay, so you have a pipe. Okay, you have a pipe and fluid is flowing within this area formed by the solid boundary. Okay, this is the solid boundary. Flows through pipes and flow in gas turbine engines, for example, or internal flows. Okay, other examples are blood or air flow in within our body. Okay, or yeah, we can give many more example. For example, pipes in various hydraulic systems, or flows within the pipe in various machines or vehicles carrying hydraulic liquids, or an example of internal flows. Okay, so this picture gives two good example of internal flows. This is blood flow through the passage within our body. This is this pipe gives us what do we call as Alaskan pipe. Okay, this is the world's longest piping system. Or probably one of the, okay, let us say one of the, it's around 1300 kilometers. Okay, so we are going to discuss about internal flows in this chapter. Okay, so the objectives of this chapter are follows. What we are going to deal in this chapter are that internal and external flows have completely different physical characteristics. Okay, so internal and external flows have different physical characteristics. Okay, in this chapter we are going to study internal flows, okay, with special emphasis for pipe flows. Okay, we are going to study the flow characteristics of internal flows, and we will focus our attention on pipes to eliminate so that we can focus on physical features, and this simple geometry eliminates the complications associated with the geometry. Okay, by pipe we mean circular cross section. Okay, we are going to talk only about pipes of having circular cross sections. Okay, the second objective is that we focus on frictional losses, or in other words we can talk about pressure drop. So these terms will become clear by the end of the chapter. So we are going to discuss about frictional losses that are experienced by the flow. This is very important because the pumping power required to move the fluid through these pipes is dependent on the frictional losses. Okay, so these two are the broad objectives of this chapter. Okay, so let us start our discussion with what do we call as laminar and turbulent flows. Okay, so let us consider flow through a pipe. Okay, so let us consider flow through a pipe, and we consider the cross sectional area of the pipe. Okay, so we can say there can be three different flow types we can encounter. Okay, we can encounter three different flow types based on the velocity. Okay, the first one is laminar flow. Okay, so at very low velocities, when flow through when the pipe flow is happening at very low velocities, okay, the flow is smooth and ordered. It's very smooth. We will observe a very smooth and ordered flow. Okay, and the flow occurs in parallel layers. Okay, and so a minimal cross stream mixing. Okay, so let us say this represents the flow. Okay, so let us say the flow is from left to right. Okay, the flow is from left to right. So if we consider one particle, it flows very smooth and ordered. Okay, so this goes along this line. The adjacent fluid particle moves along this line. Okay, so these lines that I am saying, it can be considering steady flow, it can be path line or streak line. These lines are very smooth and ordered. Okay, and flows occur in parallel layers. You can see that particles move along a particular layer, and the interaction by cross stream mixing, there is no mixing between two adjacent layers. Okay, let us say these two represent adjacent layers. Flow is happening along x direction. When we say cross stream mixing, we are talking about mixing in the perpendicular direction. Okay, cross stream, the stream is in the x direction. Okay, and the different layers in fluid interact only through molecular action. Okay, different layers interact through molecular action only. Okay, so the main feature that you should notice is that laminar flows are very smooth and ordered. Okay, the second one, the second type of flow is turbulent flow. Okay, so if we consider the same example, okay, at high velocities turbulent flows occur. Okay, so the feature of turbulent flow is that the velocity, for example, becomes random, disordered and chaotic. Ordered and chaotic. Okay, whereas laminar flow is very smooth and ordered. When the flow velocity is increased beyond a certain point, turbulent flow starts appearing. Okay, and this is characterized by random, disordered and chaotic motion in the flow field. Okay, so let us consider, if we consider a layer of one fluid particle, instead of moving along its layer, it does its own thing. Okay, it is completely disordered and chaotic. Okay, and another, if we consider another particle, what is going on? Okay, if we consider another particle, it can go in a completely disordered manner. Okay, what we have drawn is our two path lines. You know that path lines can intersect with each other. Okay, this is what we mean by random, disordered and chaotic motion. You can clearly see the difference between ordered and smooth flow field in laminar, and you can compare it with the chaotic motion in turbulent flows. Okay, so we can say that you have read that the gaseous molecules are in random motion. Here, instead of the molecules, the bulk of the fluid itself, bulk of the fluid exhibits random motion. Okay, this is like random molecular motion of gases. Okay, so we know that gaseous molecules are in random motion, but in turbulent flow, just like those random motions, the bulk of the fluid itself shows random chaotic motion. Okay, and this intense and chaotic motion leads to significant and intense mixing, intense cross stream mixing of mass, momentum and energy. Okay, and this mixing, so because of this mixing, this enhances the friction and require more pumping power. Okay, turbulent flows experiences more fluid induced friction. Okay, we are going to see this soon in this chapter. Okay, the third flow field is transition, or the third type is transition. So this occurs at intermediate velocities, the velocities in between laminar and turbulent flows. Okay, and this flow is partly laminar and partly turbulent. Okay, so by this I mean in certain regions it can be laminar, and in other regions it can be turbulent. Okay, and so in certain regions it can be laminar, and in other regions turbulent. Okay, so when we say certain regions, we are talking about distribution in space. A similar behavior can be it can exhibit similar behavior in time also. Okay, at certain point at a particular instant it can be laminar flow, after some time it can be turbulent flow. Okay, so if we plot, let's say we find a point P. Okay, so if we plot velocity at that point P with respect to time, okay, for laminar flows it'll have a very smooth variation. Okay, so laminar flow will have a very smooth behavior. Okay, turbulent flow on the other hand will be chaotic. Okay, this is turbulent flow. Okay, and the transition flow will be smooth at some time, chaotic at some other times, then it may become smooth and it may become chaotic. Okay, so this is transition. Okay, so these concepts are very important. The laminar, the characteristics of laminar and turbulent flows, you will come across this several times during other courses also. Okay, I will stop here. Along with this video, I will give a link to another video, a short one, which will give you a visual representation of laminar and turbulent flows.